Hello everyone, welcome to Techlearners. In this series of discrete mathematics, we are learning set theory and relations. We have already seen types of relations, definition and properties of relations. In this lesson, let us understand what we mean by closure of relation. So we will see two things here. One is what we mean by closure of relations. That is, we will talk about the definition of closure of relation. Then we will see the types of closure of relations. The basic types are reflexive closure, symmetric closure and transitive closure. We will see all these in the upcoming lessons one after the other, and these are just the basic closure types. We have more types of the closures. So let us understand what we mean by closure of relation. So let's see the definition. Here we can see that given a relation R, on a set A and a property P. So we have already seen what are the properties of relations, like a reflexive relation, it's one property, symmetric relation, transitive relation. So these are the properties of relations. So given a relation R on a set A and a property P of relations, the closure of R, so we always have the closure of R with respect to the property P is denoted by CL, and then we have subscripted P of R. So this is called as the symbol of the closure of the relation. CL, P stands for the property, and then R for which the closure is defined. What is this? This is the smallest relation on set A that contains two things. One is the relation and the property that satisfy the relation. Let us understand this with the help of the example. Let us say that we have a set A with few elements. Let's say we have 1, 2 and 3. And there is a relation R defined on this A. Let us say that the relation is 1 comma 1, 1 comma 2, and let us say 2 comma 2, and let's say 2 comma 3. Now we must have a property because the closure is always defined with respect to a property. Let's say the property P is reflexive. Okay. Then a relation R which will contain another relation R, which will contain this R and which will also contain this property P will be the closure of R. So let's say what will be the closure, what is the example of closure. So here this is CL, and as the property is reflexive, so we will write R as for reflexive and this R is for relation. So this will be containing the relation. First of all, let's say 1 comma 1, 1 comma 2 and 2 comma 2 and 2 comma 3. So it is containing relation, and it should also contain the reflexive property. So for this set, for the reflexive property, we should have 1 comma 1, 2 comma 2 and 3 comma 3. So let's see, we already have 1 comma 1, we already have 2 comma 3. So what we need to do is we need to include 3 comma 3. So now you can see that this relation, this new relation contains R. So you can see from here to here it was containing R, and now because of 1 comma 1, 2 comma 2 and through 3 comma 3, it is also containing the property P which is reflexive. So this will be called as the closure of relation R. Let us see one more example for the closure. Let's say if the relation A with the elements, let's say A, I and O. And now we have a relation R defined on this with the ordered pair, let's say A comma A and I comma O. Okay, now let's say again we will take one property. Let's take the property P again, and this property be a reflexive property. Okay, so this is a reflexive property. Then what will be the closure of R? Let's say for relation R. Remember, this R is the property that is reflexive, and this R is the relation. So now this must contain, this is the smallest relation that is containing the relation itself. So first of all, let me write the relation, that is A comma A and I comma O. Okay, so now this should contain the property reflexive. So for the property, we should have A comma A, I comma I, and O comma O. So we are already having A comma A. So let me include I comma I and O comma O. So this becomes the smallest relation that is containing the R as well as the property P. So this is containing R, and now it is containing the property reflexive. So this relation, this new relation, is called the closure of the given relation R. Okay, in the next lessons, we will understand how we calculate the reflexive closure, and then symmetric closure, and then transitive closure.